Hi, I have been working as assistant professor in a college for many years, and I've seen students in the undergraduate level as well as in the postgraduate level who are finding it really difficult to do a better program. So I thought this video will help all those students struggling in programming to understand the fundamentals of programming and will be able to progress and do a better and efficient program. We must accept finite disappointment but never lose infinite hope. And there are different programming languages, different tools available to solve problems. And if you understand the fundamentals of programming, it's not a matter which programming language you are choosing. All programming languages have these fundamentals. So if you become strong in the fundamentals of programming, if you understand programming better, then there is no difference in any programming language. You will be able to choose an appropriate programming language for an appropriate problem. So this video tries to help the students to understand why programming and how programming. As Dennis Ritchie has said, C++ and Java say are presumably growing faster than plain C, but I bet C will still be around. So this video tries to help students to do a better programming, and all videos which will be following will be using C as a tool to do program. So before we go into programming, we'll have to understand how do we do programming? What is the necessity of programming? So what is programming? I'm going to automate a process. The process could be something like adding two numbers, or a process could be designing a robot. Whatever the process is, we need the input, we will get the output. So in between this input and output, there will be a process. The process may get the input from the user, or the process may get the input from the memory. The process may store some data in the memory, or the process may display the data in the output device. So the input received is processed by the processor. The processed data is either stored in memory or sent to an output device. Say for example, you want to add two numbers. Now what is the input you require? The two numbers you want to add. Say for example, I want to add 3 and 5. So the input here is going to be the numbers 3 and 5. Now what is the process here? I will have to add this 3 and 5. 3 plus 5 is the process. Now what is the output here? The result which has been generated by the process 3 plus 5, that is 8. So the processed data is 8, which can be displayed on the screen or which I can store it in the memory. So for any programming, the basic fundamental components you may require is the input and the process and the output. So before we go into these components, let us try to understand what a memory is. So we have two types of memory, the primary memory, the secondary memory. So for example, the primary memory, RAM is a primary memory. Your hard disk is the secondary memory. So what is RAM? So RAM, as you all know, it is random access memory. Now what is RAM? What is actually this RAM? What is actually this hard disk? So RAM is going to be the primary memory. So if I have to work in a computer, my code and the data will have to come up to the primary memory. Then the processing will happen in the primary memory. After that, if I want to store it permanently, then I need a secondary disk for it. Say for example, let us take our study room. Assume that in your study room you have your working table and you have cupboards where you keep all your notebooks and books. So, you're asked to do some problem. You're asked to solve a problem. That's the homework, let's assume. So what we normally do, if it's going to be an assignment, you take a A4 sheet paper. You take the A4 sheet from the drawer, your secondary memory. Keep the A4 sheet on the table, which is going to be the primary memory. Work in the A4 sheet, which is kept on the table. Once you complete the work, then you want to store it safely. So you take that A4 sheet, keep it back into the drawer. So what does it mean here? If I leave the A4 sheet on the table, someone who is going to clean my room will throw the A4 sheet thinking that it's a waste into the dustbin. So what do? I take the A4 sheet which is kept on the table. Even if I have not completed the work, store it in the drawer. Then I come back when I want to resume my work, take the A4 sheet from the drawer, secondary memory, the hard disk. Keep it on the table, the primary memory. Continue my work in the primary memory. Then store back again in the drawer, which is secondary memory. I am sure you understand the basics of this. So, even when you are going to do something like this in a computer, you take the data, the code from the secondary memory, keep it in the primary memory, do all your processing in the primary memory. Once you complete or once you want to stop, you save it back to the secondary memory. So secondary memory keeps your data, your code safe. Primary memory is very similar to a working table and it is volatile in nature. It loses the data, it loses whatever it has when your system is switched off. That's the basic idea of your RAM and the secondary storage device. So moving on to the programming. So anything can be automated, anything can be programmed. Now, before I do something on my computer, what is that I need to understand? That's very important. The basic understanding of the problem given to you is very important if you have to do a efficient and an effective program. Okay, let us take an example. I'm sure everyone likes filter coffee. I like it very much. So I wanted to start this with a filter coffee. So I wanted to write an algorithm or the steps of preparing a filter coffee. So if you have to, I'm asked, this is my problem. I'm asked to prepare a filter coffee. What do I need to do? So how do I think? So I'm asked to do or prepare a filter coffee. So now in this process, I need to have two things. One is the decoction. Number two is the milk. Then I will have to mix them to get the filter coffee. This is my process. Now I can further divide these two things. Say I wanted to prepare a decoction. So what do? I need to boil water. When the water is boiling, just put the filter coffee powder into the coffee filter. Now pour the boiled water into the coffee filter. This is one way of doing. That is, keep the water container on the stove. While the water is boiling, take 2 teaspoons of filter coffee powder, put it in the coffee filter. Now the water would have boiled. Take the boiled water, pour it in the coffee filter and wait for some time to get the decoction. Now, the next step, you boil the milk. Once the milk is boiled, add required decoction and sugar if you require to the milk. Then mix it. Have a nice filter coffee. Now, there is a usual step of preparing a filter coffee. Can I interchange the steps 3 and 2? That is boiling milk first, then preparing decoction next. Yes, I can also get a coffee with this, but what is the problem here? Now I am boiling the milk. So when the milk is boiling, I am trying to prepare the decoction. And there is a chance my decoction would not have been ready when my milk is boiled. So the boiled milk will have to wait, I will have to reboil it. So the efficiency of my program, the efficiency of making a filter coffee is reduced here. So this is what is programming is. Programming is just understand the steps involved in a very proper manner. Just understand it perfectly. Once you understand it perfectly, then you're just going to write these steps in the way your computer will understand. Just like I wanted to convert something to you. I cannot converse in the language which I know. I will have to converse with you in the language you know. So if I want to communicate something to you, what do I need to do? First, I should know what I wanted to communicate. Second, I will have to say those things in the way you will understand. That's what a programming is. So first, understand the process involved in it very clearly. So once you understand the process involved in it, then communicate to the computer in the manner your computer will understand it. This is simple programming. That's all. The computer understands many languages. Now, you will have to choose a language which both you and your computer will know. One choice. Number 2, which language will be better for this problem? So based on all these factors, you will just communicate with the computer. That's it. So before you communicate with the computer, the first step is understanding the problem very clearly. Let us take another example. I just want to find the greatest of two numbers. How do I do? So what is the input required here? The two numbers which I want to compare. That's the input. So I need to get the two numbers. Say, you're asking me a question. Find the greatest among 5 and 7. Now what is the input? Numbers 5 and 7 is the input. Now the process is, I'm going to compare these two numbers. That's the process. Once I compare it, then I will have to display, yes, 7 is the greatest number. So I need to know the input. I need to know how do I solve the question asked, solve the problem asked. Then I will have to give the answer. So it's very, very, very simple. Before you do programming, first of all, try to understand all types of problems which are just around you. Say for example, you wanted to start from your house to college. How do you go? Find out. Just try. Brainstorm. You have different ways of going. Take a metro, take a bus, walk, take a auto, take a cycle, take a two-wheeler, take a car, go through ABC or go through XYZ, go through AXB. There are different ways of going. Just brainstorm all this and find out which one is best. How do you arrive at it? The money, the time involved, the distance traveled, the mode of transport, the availability. There are so many factors which you need to consider to solve any problem around you. The same thing applies to computer programming also. So please everyone, Computer programming is very, very, very easy if you understand how are you going to solve the problem given to you. So, it's not important to learn a programming language. It's very, very important to understand the problem and find out different methods of solving the problem, find out effective method for solving the problem. Only after this, you need a language to communicate with the computer to work on this problem. I just complete this video with a quote by Dog Linder. A good programmer is someone who always looks both ways before crossing a one-way street. So, I'm sure you will understand how do we proceed with programming. I've just given this video because whenever a program is given, whenever a problem is given to students, students start to type the code in the computer. But that will not get you a solution. Before you start using your computer, you will have to take some time to understand how we are going to solve this problem. Only then you'll have to proceed with programming. So to understand this, just try different problems around you. You wanted to brush your teeth. Fine. What is the step involved? If it's going to be in the morning, get up from bed, walk to the washroom, take your toothbrush and put the paste on the toothbrush, then start brushing your teeth. This is just the problem just being solved. Anything and everything requires a step-by-step process to complete the task. That's it, students, for the day. Thank you all for watching the video.